Find the directional derivative of the function f at 2 pi 0 along the vector a. So the directional derivative written as d for the function f along a, the vector a, will be equal to gradient of the function. This is a scalar function. So gradient of this scalar function dotted with the unit vector along the direction of a, because a vector divided by magnitude of a is the unit vector along the direction a. So to find the directional derivative of a scalar function along a vector can be found out by taking the gradient of the scalar function dotted with the unit vector along the given vector. And we know gradient of a scalar function can be represented by the del operator or del of f. Here I have written gradient of f means del of f dotted with the unit vector, that is a vector divided by magnitude of a. And the del operator can be written as I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z. And the given scalar function is e to the power x cos y. So here f is equal to e to the power x cos y. So we have to take the partial derivative of this scalar function with respect to x, then y, then z. And the given vector a is here 2i cap plus 3j cap, and divided by magnitude of the vector a, that is equal to 2 square plus 3 square square root. If you take the partial derivative of the scalar function, that is e to the power x cos y with respect to x, then this will be equal to e to the power x cos y, because derivative of e to the power x is e to the power x, and to cos y, minus, if you take the partial derivative of this with respect to y, then this will be equal to e to the power x, and derivative of cos y will be equal to minus sin y. So j cap e to the power x sin y. Since there is no z component, so this component have no value, and solving this 2 square plus 3 square, that is equal to 4 plus 9 square root, and in the numerator you have 2i cap plus 3j cap. Now let us solve it, and it is given to find the directional derivative of the scalar function at the point 2 pi 0. So we have to find out the directional derivative of the scalar function f for the vector along the vector a at the point 2 pi 0. That means you substitute the value of x equal to 2, the value of y equal to pi, and the value of z equal to 0. Here there is no 0, so only you substitute the value of x and y. So I cap e to the power x means e to the power 2, that is e square cos y. Y value is pi, so cos pi, minus j cap e to the power x means e square, because x value is 2, and sin y, y value is pi, so sin pi, and this value 2i cap plus 3j cap divided by 4 plus 9, that is 13, so square root of 13. And if you solve it, this will be equal to, you see here I cap, so I cap dot I cap is equal to 1, so e square into 2, so 2 e square into cos pi. Similarly j cap dot j cap is equal to 1, so 3 e square, so minus 3 e square, here is minus, so 3 e square into sin pi divided by square root of 13. So we know sin pi, this will be equal to 0, so this second term will be equal to 0, only you have this term, because cos pi is equal to minus 1, so the numerator value will, the value in the numerator will be equal to minus 2 e square, so minus 2 e square divided by square root of 13. In this way you can find out the directional derivative of the given scalar function e to the power x cos y at the point 2 pi 0 along the vector a, that is equal to 2i cap plus 3j cap.